This is a video about experiment number 4. This is a low-pass filter, and we'll take a look at the fact of capacitor reactance, how it affects in a series circuit the signal. Capacitors are frequency selective devices, and again their reactance changes with frequency, so this experiment will bring a lot of those concepts out. You might take a look at the proto board and you see a 1200 ohm resistor. It's a 0.01 microfarad capacitor. This is the input to the circuit. Here's the output of the circuit, and we're going to drive it with a signal generator over here, and we're going to take a look at the output with the oscilloscope here. So I'm going to move the camera a little bit closer to the oscilloscope, and hopefully we'll have a nice picture of the there's an automatic focus here. Let's see if we can get this to take and give us a nice view of the scope. Try the automatic focus one more time. There we go, a lot better, I guess. Not too sure about that, but hopefully a little bit better. And unfortunately, sunlight is coming in and on the giving us a little problem. Let me just take it, close the blinds here a little more. Now, unfortunately, you can see a reflection of myself and the camera, but such is life. So let's take and right now we have an input signal of 10.2 volts. Let's just say that's 10 volts. Output amplitude is 10 volts or 9.9 volts at a frequency of 100 hertz. So if you go to the experiment, it turns out we want to take and make measurements of the various outputs and phase angles and so forth, and that's the other thing you see on the scope. On the bottom measurement is the phase angle between 1 and 2 is 11 point, bouncing around, let's stop it here, 11.69 degrees. So that's the first measurement. So you put that in your chart in the experiment. Let's go to 200 hertz, and we go to 200 hertz, and it turns out that 200 hertz, not much has changed. 10 volts going in, 10 volts coming out, about again 11.73 degrees. I'll make a comment here that the scope takes and can measure the phase angle, but you might notice that the cursors are jumping around, and the cursors are what make the measurements. So when they jump around, the accuracy is not as good as you might want. And the other thing is, I'm not too convinced that the accuracy is, it should be close to 0 degrees right now, and it's about 10, 11 degrees. So the accuracy, we'll see what happens at higher frequencies. I think the accuracy will be even worse. But we'll use it anyway. So let's go up to 400 hertz. Next measurements at 400 hertz. Inputs 10.2 volts, outputs 9.6 volts, and the phase angle 17, well, we'll stop at 17.28 degrees. So that's at 400. We're going to go to the next measurement at 600. So let's go to 600 hertz. And at 600 hertz, 10.2 volts. Looks like the output's starting to go down. It's 9.1 volts. Our angle is about 24. Let's stop it again. 24.5 degrees. So that's at 600 hertz. Let's go to 800 hertz. At 800 hertz, our input's still 10 volts. Our output now is down to 8.7, and our phase angle is 31.5 degrees. Let's go to 1 kilohertz. Our next measurement at 1 kilohertz shows that, let's take and change the time scale here, 10 volts going in, 8.1 volts coming out, 37 degrees roughly, 37.35 degrees for the phase angle. Let's go to 2 kilohertz, and at 2 kilohertz now we notice that the signal has gone down quite a bit. The green one, which is the output, yellow is the input, Still 10 volts going in, 5.6 volts going out, about 55.66 degrees for the phase angle. There's a measurement later on, and I'll do it right now. Where is the phase shift 45 degrees? That would be where the resistance of the resistor is equal to the reactance of the capacitor. And let's take and see if we can find that frequency. I'll go and adjust my signal generator. I'll go and turn the scope back on so it's measuring. I go down to 1900 hertz, 1800, 1700 hertz, 1600 hertz, 1500 hertz, 1400 hertz. I'm at 46 degrees. And if I go here to 1300 hertz, well, let's take and stop the measurement. 45.5, 44.3, 45.34. So somewhere around 1300 hertz, or 1.3 kilohertz, is where my phase angle is 45 degrees. Another interesting thing you see is that the voltage going in is 10 volts and the output amplitude is about 7.2 volts. So roughly 72% of the input is making it to the output. It turns out that that's what we call the minus 3 dB point, and this would be the cutoff frequency. So there's a measurement later on in the experiment that I ask you for the 45 degree angle frequency, and it's about 1300 hertz. Okay, so we were at doing 2 kilohertz, so let's go play with our signal generator again and bring that back up to 2 kilohertz. And then the next signal frequency we want is 4 kilohertz. At 4 kilohertz, we still have 10 volts going in, 3.3 volts coming out now, and our angle is about 69.28 degrees. Let's move on to 6 kilohertz. And at 6 kilohertz, I'm going to turn up the gain for the output, change the time base, and now we have 10 volts going in still, 2.19 volts coming out, and a phase angle of about 76.8 degrees. Let's go to 8 kilohertz. At 8 kilohertz, 9.7 volts going in, 1.67 volts coming out, and a phase angle of about 79.3 degrees. Let's go to 10 kilohertz. At 10 kilohertz, we've got 9.7 volts going in, 1.35 volts going out, or coming out, and 81.38 degrees for the phase angle. So the phase angles are going to get fluky, wonky, whatever you want to call it, so let's bear with them. We'll go to 20 kilohertz. 20 kilohertz, 9.7 volts going in, 700 millivolts coming out, and about 84 degrees for a phase angle. We'll go to 40 kilohertz. At 40 kilohertz, let's turn up the gain here, and time base also. 9.7 volts going in, 334 so millivolts coming out, and 87.3 degrees for the phase angle. We'll go up to 60 kilohertz. At 60 kilohertz, 9.7 volts going in, 229 millivolts coming out, and 86.55 degrees for the phase angle. And again, at this point, the phase angle is probably very suspect. We'll go up to 80 kilohertz. 80 kilohertz now, 9.7 going in, 173 millivolts coming out, and the phase angle is kind of just hanging there at 86.77 degrees. The maximum it can get is 90, and I don't think it'll hit that. Matter of fact, it might regress. Let's go to 100 kilohertz. 100 kilohertz, 9.7 volts going in, 141 millivolts coming out, 86.2 degrees for the phase angle. Let's go to 200 kilohertz. And at 200 kilohertz, turn up the output here, change this scale also. 9.7 volts coming in, about 70 millivolts coming out, and the phase angle jumping around 86.85 degrees. One last measurement at 400 kilohertz. At 400 kilohertz, we have 9.7 volts going in, 36 millivolts coming out, and the phase angle is rather indeterminate at 86.2 degrees. So those are the measurements for experiment number 4.